To- My topic is about high speed complex numbers multiplier and the inner product processor. Today we say about the introduction to the complex number multiplication. Complex numbers are essential in various fields, various speed communications and mm, control system. Multiplication of the complex numbers involves both real and imaginary components requiring specified computational techniques. High-speed complex numbers multipliers enhance the performance of a digital system by reducing computational delays. Importance of the inner product processor. Inner product. Mm, the inner product is a fundamental operation in mathematics that has applications in machine learning applications in machine learning applications in machine learning to a data analysis provides the measure of the similarity between vectors, which is crucial. Algorithms for pattern recognition. High-speed inner product processor enable real-time computational signification, improving efficiency of data-driven applications. Traditional methods of complex multiplication. Conventional methods for complement multiplication relay calculations for real and imaginary. These methods can be inefficient due to increased number of arithmetic operations required. Understand traditional methods such as stage for exploring high-speed techniques that improve performance. Understanding traditional methods sets the stage of the exploring high-speed techniques that improve performance. For examples in the figure, AC minus BD plus I into AD plus BC, high-speed complex multiplier architecture. High-speed complex multipliers often mm, High-speed complex multipliers often utilize specialized hardware architecture mm, such as pipelining and the parallel processing. This architecture allows simultaneous calculations which dramatically reduce latency and increase throughput. Examples includes use the Cordic algorithm and the dedicated DSP digital signal processing blocks for optimization. Algorithms for efficient complex multiplication. Algorithms such as mm, Karas- Karatsuba and the Doom-Cook methods can be adapted for faster complex multiplication. These algorithms minimize the number of multiplications needed for speed of the overall computational. Implementing these algorithms in the hardware can lead to significant gain in processing speed. Overview of the inner product processor design. Inner product is the dot product. For dot product, where there is a one row and the three columns. The inner between the row and the columns are the very different between the inner product. First, we should do the multiplication with the inner mm, the inner product processors are designed to efficiently compute the dot product for two vectors. They often employ multiple arithmetic units to perform simultaneous calculation, improving performance. The architecture can be optimized for specific applications such as digital filtering, integration of the complex multipliers of the inner product, the integrating complex multipliers with the inner product platform for advanced computation. This integration is particularly beneficial in applications like radar signal processing and the communication. It enables systems to handle complex data far more efficiently, leading to improved performance in real-time applications. Inner production and the applications of the signal processing, high speed complex numbers, multipliers and the inner product processor of the crucial of the modern signal processing techniques. Applications and the modulation, demodulation in communication systems. The ability to perform these operations quickly enhance the overall system responsibly and effectively. So, challenges in implementation of the high-speed complex multipliers and the inner product processor poses high challenges. Designers must have his suppressors speed area and the energy efficiency to meet the requirements of modern applications. Overcoming these challenges often involves innovative design strategies and the use of advanced materials technologies, and there are some challenges. Strategies must always evolve in response to their effectiveness and the changing external conditions. And the second challenge, restructuring an organization to meet strategies goals can silo business units in effort to protect their turf. They become less cooperative. Managers want their teams to run efficiently with the conflict with strategic goals. Formulation, implementation, and the executions are intertwined, so the company or the business unit yields pure results over multiple years. It can be hard to determine which stage is to crash. And there are some criticisms. Executive team put most of their energy into creating the strategy, but not enough effort to implementation and execution. It can be painful for employees when their company is restructured to fit a new strategy. Mm, there is a built-in disconnect because corporate strategy is the responsibility of executives, but the execution is the responsibility of business units. Strategies can never be fully implemented because assumptions made during the formulations are constantly changing. These are the challenges or implementations of the further trends and the developments. The demand for faster and more efficient complex number computation continues to grow with the advancements in AI and the IoT. Nowadays AI becoming more future development may focus on integrating machine learning algorithms directly into hardware for enhanced performance. Ongoing research aims we explore materials technologies that are further improve the speed and efficiency of these processes. Feel free to adjust or expand upon any of the time. And these are the future trends and the developments. Challenges in implementing high speed complexes multipliers and the multipliers are the inner product processor poses various challenges including power consumption. Also these designers must balance speed area and the energy efficiency to meet the requirements. The ability to perform these operations quickly enhance system responsiveness and the effectiveness. There are some, and we see in this diagram match filtering course of the fine changed applications include Fourier transformation, filtration, this modulation, demodulation, and the communication systems. These are some applications. Integration of the complex multipliers and the processes. These are then some conclusion. Last final conclusion is feel free to adjust or expand any of the future trends and the developments.